I'm Betty D, and in this video we're going to be looking at how to find the area of a triangle. So in a previous video on the area of a rectangle, we found that the area of a rectangle is given by A equals L times W, or the area equals our length times our width. Okay, that's incredibly important because that formula can be modified to find the area of any shape at all. And in this case, we're going to look at using this formula to find the area of a triangle. So what we need to start off with is a triangle. So I'll switch colours there. So we've got a triangle here. Right, and we want to know its area. How many of these squares, okay, does it take up? Well, as I said, we can look at utilising this formula here. But in order to be able to do that, we just need to do a little bit of work first. And that's to realise that this triangle, and in fact any triangle, can be turned into a rectangle. Okay? We can turn into a rectangle. In this case, our rectangle has a width of 3 units and a length of 4 units. Okay? But we can see here that our nice purple triangle, right, is actually only half of our rectangle. Okay? Half of our rectangle. So if we work out the area of our rectangle using A equals L times W, we see that our length is 4 units by our width, which is 3 units, which gives an area of 12. In this case, we're going to call these centimetres. 12 centimetres squared. Now that's the area of a rectangle though. When we have a look at our triangle here, right, we can see it's only taking up half of our rectangle. So the area of our triangle is going to be half of 12, which is 6 centimetres squared. 6 centimetres squared. So what we can do here is go, well actually, hang on a second, we can actually write an equation for the area of our triangle by modifying this area of a rectangle. So we can say, well, our area, A, is going to equal, it was a half times our length times our width. Okay? Now for a triangle, we actually talk slightly different languages. Instead of length and width, you'll often hear the term base and height. So area can equal a half times the base of our triangle times the height of our triangle. So we call this one our base, this one our height. Now what's super duper important is to remember our definition of a rectangle. A rectangle had 2 sets of sides that are parallel and opposite sides are equal length, but we also have a right angle in each of our corners. So what's really important is that we realize that our length and our width, those dimensions, are at right angles to each other or perpendicular to each other. So in this formula, our base and our height must be at right angles to each other. Because as you would have seen before, there's lots of different ways to draw triangles, but this rule will work for all of them. So we have a look at another example. Let's go to this triangle here. Okay. So if we're looking at our formula, area equals a half base times height, we're going to apply it to this one. Right? You might be tempted to say our area equals, we've got this length here, which we'd say is our base. Now, most people can identify that would be our base. Right? And we could say 4 centimetres. Right? But people start looking at height and going, okay, well, how high is it along here? What's this length here? Okay, but we've got to be careful because this angle here, okay, is not a right angle. So we need to be looking at going, well, where is our height dimension? Well, it's actually straight up the middle. Straight up the middle there. And in this case, it would also be 4 units. Okay, now you might be thinking, well, that doesn't make sense though, because I'm not going to end up with a rectangle. Well, we can, it's just our rectangle is going to be around our triangle like this. Now our triangle is taking out this central part, and seeing this height dimension that I put on, we can see that this side of our triangle, okay, will be half of this rectangle on this side, and similarly on this side, this triangle here is going to be half of the bigger rectangle going around it. Okay? So our formula still works. Overall, this triangle is half of this rectangle, which is in fact a square this time. So we work that out, we go a half times 4, Well, that's 2 times 4 is 8 centimeters squared. Okay. Now this one still wasn't too bad to see. However, they can be more difficult. In that case, we had a isosceles triangle. The one that often tricks people is if we have a scalene triangle like this. So it's looking much more tricky. Well, where's our base and our height? Well, if I call this my base, where's my height going to be? Is it either of these lengths? Well, no, it can't be because we know that we don't have right angles there. Could I draw a line up the middle here? Well, that kind of gives me a triangle here that I could work with, but doesn't help over there. So that hasn't worked so well. In fact, what we need to do is think about rotating this triangle around so that our longest side is our base from here to here, and call that our base. And we actually need to draw a line that's coming from this base at right angles to our point over here. Okay? And the reason why you can do that is so that then we can surround our triangle in our rectangle. Okay? So we're looking at something like that, where you can see we've got a big rectangle here, and now we can see, well, particularly with this line here, okay, that this triangle in here is half of this rectangle, and this triangle in here is half of this bigger rectangle as well. So overall, my triangle that I've got is equal to half of this rectangle. Right, now it's not clear on here what our dimensions would be, okay, but our formula is still going to work, and this is where you might need to measure it. You might be given those dimensions, but our area, let's say our base is, in this case, 7 centimeters, and our height, let's call that 3 centimeters. So our area is going to be a half times by 7 times by 3. Well, we know 7 3s are 21, and a half of 21 is 10.5 or 10 and a half, and they'll be centimeters squared. So the main things to remember with this is that our area of a triangle formula is simply half of the area of a rectangle, and you need to make sure that when you're looking at our two dimensions, they've got to be at right angles to each other. That is key, otherwise our formula doesn't work.